Hi everybody, so as mentioned, I'm going to be going through these questions, the questions that came from exercise 10C question 5. So hopefully you've had a go at some of these and you can see how I would do these. So for the first one, I'm going to start with the left-hand side. It looks the most complicated. I've noticed straight away that I can expand that. So expanding the double brackets, I'll get sine squared theta plus sine theta cos theta, sorry, 2 lots of that, plus cos squared theta. Now, I can see an identity straight away. Sine squared theta plus cos squared theta equals 1. So these two will be equal to 1. So I'll be left with 1 plus 2 sine theta cos theta. And as you can see, that is the right-hand side. So that one's done. Now, on the next one, I'm going to start with the left-hand side. And straight away, it's not looking very obvious of what to do here. I have an identity with tan and having sine theta over cos theta, but I don't really have a tan on this side just yet. So what I'm thinking of doing is making the minus cos theta, writing it in terms of cos squared theta over cos theta. That would just still give me an answer of cos theta. And why am I doing that? Well, I can make these two parts into the same fraction now. And they both have a denominator of cos theta. So I'm just going to combine the numerators together and write it over the same common denominator. Now 1 minus cos squared theta is equal to sine squared theta. So I'm going to change that to sine squared theta. And I'm looking at the right-hand side. I've got to get to a sine theta, tan theta. And really, if I had a sine theta over cos theta, that would give me a tan theta. So what I'm going to do is I'm going to rewrite the sine squared theta as 2 sine thetas multiplied together. And I could even just write a sine theta on the outside multiplied by sine theta over cos theta. And there I have the right-hand side. Once I change sine theta over cos theta to tan theta, that's the other identity there. So I am left with the right-hand side. Now, it wasn't the nicest question. You could have started with the right-hand side here, changed your tan theta into sine theta over cos theta, multiplied to get sine squared theta over cos theta, change sine squared theta into 1 minus cos squared theta. You'll still have your cos theta on the bottom. And then you could have split up your fraction and then be left with the left-hand side. So in this case, it might have been easier to start with the right-hand side and get to the left-hand side. So if you're not having much luck with one side, before you give up, maybe try starting from the other side. We've not seen much of this technique so far, where I had to manipulate the cos theta and write it as a fraction. So if you thought that was a little bit confusing, maybe something that you wouldn't remember when doing it yourself, try it the other way and see if that would be beneficial for you. Let's go to the next question then. So I've got tan x plus 1 over tan x is identical to 1 over sine x cos x. So I'm going to start with the left-hand side just because I've got two things there. I'm going to change the tan x to sine x over cos x using that identity. I'm going to do it to both. So there and also here. Now we saw this going through the examples. This is a 1 over sine x cos x. Sine x over cos x, sorry. A 1 over the other fraction. So it's like doing the reciprocal of the fraction. So if you define the reciprocal of this, you flip the fraction. So that's how I would write it that way. So sine x over cos x plus cos x over sine x. That's what I'm going to be left with. Now, I'm going to combine the two fractions together. I've just had a quick look at the right-hand side. I've got a cos x and a sine x on the denominator multiplied together. I can get a sine x and a cos x multiplied together by making my fractions have the same common denominator, a common denominator of sine x multiplied by cos x. So I'm just going to keep with the order I've got, so I'll leave it as cos x multiplied by sine x for the time being. Remember, these can be changed around the order, it won't matter. Now the first fraction, the denominator has been multiplied by sine x, so I'll have to do the same with the numerator. So multiplying by sine x will give me sine squared x. And the second fraction, the denominator has been multiplied by cos x, so I'll have to do the same to the numerator and multiply by cos x, so it'll become cos squared x. As you can see, there's going to be an identity that I can use on the top there, the numerator, and I can make it into a 1. So I'm not far off. I think I'll just be clear and write the denominator the other way around to show that I've ended up with the right-hand side. So that bit's done. Okay, I'm going to move on to the next one. We've got cos squared a minus sine squared a is equal to 2 cos squared a minus 1. Now I'm going to start with the left-hand side. I've just chosen to start with the left-hand side just because I think I can undo that and end up with the right-hand side, but this one is not really much in it between what you start with. Sometimes it's best to start on the side where you got an idea of how you can start manipulating it. So remember, this isn't an identity. We've got to have an add there for the two terms to be equal to 1. But I could change sine squared a into 1 minus cos squared a. So that's what I'm going to do. And just sorting that out, I'll have cos squared a minus 1 and then cos squared a plus cos squared a. Okay, so I'll write that bit out. The minus with the minus will make it a plus cos squared a. And I can collect the two cos squared a's together. And there I've been left with the right-hand side. So I've got to the right-hand side for that one. Let's have a look at the next two questions. So the next one, straight away, I'm going to be using the left-hand side because it's way more complicated than the right-hand side. So I'm going to start expanding this. It's going to be quite a long line. I'm going to have 4 sine squared theta minus 4 sine theta cos theta plus cos squared theta. That's the first bracket expanded. Remember, it's double bracket expansion. Next, I'm going to have sine squared theta plus 4 sine theta cos theta plus 4 cos squared theta. So I've expanded both brackets now. Let's see what I've got. Well, these two terms will cancel, got a positive and a negative version of the same term. These are going to be equal to 1 using the identity. So I will have 4 sine squared theta. I'll write the 4 cos squared theta next, and then I'll add a 1. Now, there is an identity here if I pull out a factor of 4. So 4, and then open brackets, sine squared theta plus cos squared theta. So I've factorised those two terms, and then I'll have a plus 1. Now, this part of the bracket is equal to 1 using the identity. So I'm going to be left with 4 plus 1, which is 5, which is the right-hand side. All right, the next one. I'll move a little bit lower. Again, I'm going to probably start with the left-hand side. So the left-hand side is equal to 2 minus brackets sine theta minus cos theta all squared. So I'm going to expand the brackets. I'm going to keep my answer in a bracket because I've got a minus before it. So I'll have sine squared theta minus 2 sine theta cos theta plus cos squared theta. Now I'm going to apply the minus to everything. I'm multiplying by minus 1. So I'll have 2 minus. Now, actually, before I do that, I've just noticed that I've got a sine squared theta and a cos squared theta. So before I multiply through by minus 1, that is going to be 1. Just making it a little bit simpler. So doing what I was saying before, multiplying through by minus 1, I will get that. And I'm going to be left with 1 plus 2 sine theta cos theta. And that's really as far as I can go. So how am I going to get to show that this is equal to the right-hand side? Because it doesn't at the moment. Well, I can still manipulate the right-hand side. So let's start with the right-hand side. And expand. I've got an identity here, sine squared theta plus cos squared theta equals 1. So I'm going to be left with 1 plus 2 sine theta cos theta. And as you can see, I've got the same thing now. So the left-hand side became 1 plus 2 sine theta cos theta, and the right-hand side became 1 plus 2 sine theta cos theta. So the left-hand side is equal to the right-hand side. So something different to trigonometric proof, something different to what we've seen so far. I'm going to do the final question now. So it looks like I'll be starting with the left-hand side again. There's way more terms on the left-hand side than the right-hand side. It looks more complicated. So the first thing I'm going to do is change the cos squared y and the cos squared x into 1 minus sine squared y and 1 minus sine squared x. Why am I thinking of doing that? Well, then I just get everything in terms of sine, and I'm looking at the right-hand side. Remember, you can use that as a clue. I only have terms involving sine. So I'm using the identity here twice. Cos squared y is the same as 1 minus sine squared y. And cos squared x is the same as 1 minus sine squared x. And I've got the sine squared y there. I've just put that bit in a bracket because I've got this minus, so I don't want the minus to cause an error here. So now I'm going to expand everything because I've got brackets to expand now. So I'm going to have sine squared x multiplied by 1, which is just sine squared x. Sine squared x multiplied by minus sine squared y. Well, that's going to be minus sine squared x sine squared y. I can't make those equal to each other. There's a different variable x and y involved. Then I'm going to have, now if this is going to be too complicated, I could write the sine squared y and the minus 1 together, and then the other bracket like that. Remember, everything's being multiplied here, here, and here. So if I do it this way, I'm going to be getting minus sine squared y when I multiply it with the 1, and then I'm going to have a plus sine squared y sine squared x. Now, these will cancel this and this. I can rewrite this the other way around. It's still going to be the same thing. And then I've got the negative version of it over there. So those have cancelled. And I'm just going to be left with sine squared x minus sine squared y. And that is the right-hand side. Okay, so I hope that's helped with some of the questions you've had to do on trigonometric proof. To finish, you might want to just have a look at this one. Remember, with these questions, you know you've got to the right answer if you've got to the other side, and hopefully you've not broken any maths in between your stages. So have a look at this one. I'm not going to go through this one. So prove that tan theta plus 1 over tan theta is equal to 1 over sine theta cos theta.